topic at hand involves a proposed code change to the National Electrical Code, specifically Section 680.74 from the 2008 NEC, dealing with double-insulated motors. The current code states that double-insulated motors shall not be bonded. The proposal suggests changing this to "it shall not be required to bond them." The main point of contention is whether prohibiting bonding entirely is necessary, or if allowing it under certain circumstances offers more flexibility without compromising safety. Let's examine the arguments for and against this proposed change. Firstly, let's consider the arguments for changing "shall not" to "it shall not be required." One major advantage is flexibility in design. By allowing designers to consider bonding double-insulated motors in specific circumstances, the code becomes more adaptable to unique situations where additional protection or safety may be desired. For example, in environments with high electrical noise or sensitive electronic equipment, bonding might offer an extra layer of protection against electromagnetic interference or voltage transients. Secondly, consistency with other standards plays a role. Some other standards, such as the Canadian Electrical Code, permit the bonding of double-insulated motors in certain situations, such as hazardous locations. Aligning the NEC with these standards could simplify design and installation processes for projects that span multiple jurisdictions. Thirdly, there is the argument that there is no evidence to suggest that bonding double-insulated motors would have any detrimental effects on their performance or safety. Double insulation provides a high level of protection against electric shock, and adding a bonding connection is unlikely to compromise this protection. Now let's consider the arguments for retaining the "shall not" requirement. One major concern is potential confusion and misinterpretation. Changing the language could lead to confusion and misinterpretation by users, particularly those who are not familiar with the specific requirements for double-insulated motors. The current wording is clear and unambiguous, leaving no room for interpretation. Secondly, there is the consideration of potential hazards. Although unlikely, bonding double-insulated motors could create potential hazards, such as creating a path for current to bypass the insulation if one layer fails. In this scenario, the bonding conductor could become energized, posing a shock hazard. Thirdly, consistency with historical practice matters. The "shall not" requirement has been in place for many years and has ensured that double-insulated motors are not bonded in most applications. Maintaining this requirement would preserve the status quo and avoid introducing any unforeseen consequences. The decision of whether to change the language from "shall not" to "it shall not be required" is a matter of balancing the benefits of flexibility and consistency against the potential risks and confusion. While allowing bonding in certain circumstances might seem appealing, it is essential to carefully consider the potential implications for safety and code interpretation. One must consider several factors before making a final decision on this code change proposal. These factors include the potential for increased flexibility in design, the need for consistency with other standards, and the potential risks associated with bonding double-insulated motors. To elaborate further, the flexibility argument suggests that allowing bonding under specific circumstances could benefit certain applications. For instance, in industrial environments with heavy machinery or corrosive atmospheres, additional grounding might enhance safety and reduce the risk of electrical faults. Furthermore, consider the alignment with other standards. If international or regional codes permit bonding in similar situations, aligning the NEC could simplify design and installation for multinational projects. It is also crucial to weigh the potential risks associated with bonding. While double insulation provides a high level of protection, adding a bonding connection could introduce new failure modes or create unintended current paths. A thorough risk assessment should be conducted to evaluate these potential hazards. In situations where specific safety or protection requirements justify bonding, it is crucial to provide clear guidance and instructions in the code commentary or explanatory notes. This would help ensure that installers and inspectors understand the rationale behind the bonding and follow proper procedures. Furthermore, it is important to consider the potential impact on existing installations. Changing the code could create confusion or require modifications to existing systems. A careful transition plan should be developed to minimize any disruptions or unintended consequences. In conclusion, the decision of whether to change the language from shall not to IT shall not be required is a complex one that requires careful consideration of multiple factors. While allowing bonding in certain circumstances might offer increased flexibility and alignment with other standards, it is essential to carefully weigh the potential risks and ensure that proper safeguards are in place. It would be reasonable to amend the language to IT shall not be required to provide additional flexibility in design and align with other standards. However, it is crucial to emphasize in the code commentary or explanatory notes that bonding of double insulated motors is generally not recommended and should only be considered in exceptional circumstances where specific safety or protection requirements justify such a measure. To provide a more detailed understanding of the potential implications, let's explore specific scenarios and applications where bonding might be considered or discouraged. In hazardous locations, such as those with flammable gases or combustible dust, additional grounding and bonding measures are often required to minimize the risk of ignition. In these environments, bonding double insulated motors might be considered to provide an extra layer of protection against static discharge or electrical faults. However, it is crucial to carefully evaluate the potential risks and ensure that the bonding system is properly designed and installed to avoid creating new hazards. In sensitive electronic equipment, such as medical devices or computer systems, electromagnetic interference can disrupt performance or cause malfunctions. Bonding double insulated motors in these environments might help reduce interference and improve the reliability of the equipment. However, it is important to use appropriate bonding techniques and materials to avoid creating ground loops or other problems. In corrosive environments such as chemical plants or wastewater treatment facilities, electrical equipment is exposed to harsh conditions that can degrade insulation and increase the risk of electrical faults. Bonding double insulated motors in these environments might help provide an additional path for fault current to flow, reducing the risk of electric shock or equipment damage. However, it is crucial to use corrosion-resistant materials and ensure that the bonding connections are properly protected. In residential applications, bonding double insulated motors is generally not recommended unless there are specific safety concerns or code requirements. Double insulation provides a high level of protection against electric shock, and adding a bonding connection is unlikely to provide any significant additional benefit. However, in certain situations, such as when a motor is installed in a wet or damp location, bonding might be considered to provide an extra layer of protection. In commercial applications, such as office buildings or retail stores, bonding double insulated motors might be considered to reduce the risk of electrical noise or improve the reliability of equipment. However, it is important to carefully evaluate the potential benefits and risks and ensure that the bonding system is properly designed and installed. Furthermore, it is crucial to provide clear guidance and instructions in the code commentary or explanatory notes to help installers and inspectors understand the rationale behind the bonding and follow proper procedures. This would help ensure that the bonding is done safely and effectively and avoids creating any unintended consequences. It is important to consider the potential impact on existing installations. Changing the code could create confusion or require modifications to existing systems. A careful transition plan should be developed to minimize any disruptions or unintended consequences. This transition plan could include providing training and education to installers and inspectors, developing clear guidelines and procedures, and offering technical assistance to those who need it. Additionally, it is important to monitor the effectiveness of the code change and make adjustments as needed. This could involve collecting data on electrical incidents, conducting surveys of installers and inspectors, and holding public hearings to gather feedback from stakeholders. In addition to the technical considerations, it is also important to consider the economic and social implications of the code change. For example, changing the code could increase the cost of electrical installations, which could disproportionately affect low-income individuals and families. Additionally, the code change could have implications for employment and training in the electrical industry. Therefore, It is important to carefully weigh the potential benefits and costs of the code change before making a final decision. In conclusion, the decision of whether to change the language from shall not to IT shall not be required is a complex one that requires careful consideration of multiple factors, including the technical, economic, and social implications. While allowing bonding in certain circumstances might offer increased flexibility and alignment with other standards, it is essential to carefully weigh the potential risks and ensure that proper safeguards are in place. The NEC should provide clear guidance and instructions to help installers and inspectors understand the rationale behind the bonding and follow proper procedures.